Hello students, today's topic is the temperature dependence of resistivity. So when temperature increases, the resistivity will also change. For different materials, it will change differently. For some, it may increase and for some, it may decrease. So let us find out what happens to the resistivity of a metal with the increase in temperature. As we know, the equation for resistivity is rho is equals to m divided by n e square tau. So here m is the mass of electron, e is the charge of electron, n is the number of electrons per unit volume, that is number density, and tau is the relaxation time. So as you can see that m and e is constant, so it is depending upon the number density inversely, and it is also depending upon the relaxation time inversely. But in actual, the n, that is the number density, is not dependent on temperature to any appreciable extent. So we can say that rho is independent of n with increase in temperature, or we can say that the n is independent of temperature. So only thing left, that is rho is inversely proportional to the relaxation time. So rho is inversely proportional to relaxation time. So what will happen with the increase in temperature? So if temperature increases, what will happen? Inside the conductor, the electrons will vibrate more vigorously and they collide with the positive ions with a high speed than as before. So if the speed increases, then obviously the time will decrease. Time of collision will also decrease. So if time decreases, means we can say that the average time, or that is relaxation time, will also decrease. So we came to know that with increase in temperature, the electrons will vibrate more, or they will move with high speed. If speed increases, then the time of collision will decrease, and we can say that the relaxation time will also decrease. So with the decrease in relaxation time, the resistivity will increase, as the rho is inversely proportional to tau. So what is the conclusion? That with the increase in temperature, the resistivity will also increase. So with the increase in temperature, the resistivity will also increase. That is for the case of metal. So the resistivity of a metallic conductor is approximately given by the equation, that is rho T is equals to rho naught 1 plus alpha T minus T naught. That we can also write as rho naught 1 plus alpha del T, where del T is T minus T naught. So rho naught is the resistivity at the temperature of T naught, and rho T is the resistivity at temperature T. And the alpha is a new term here, that is termed as temperature coefficient. Alpha is termed as temperature coefficient of resistivity. So this is a constant, and its unit, or we can say its dimension, is temperature inverse. This alpha is positive for metals. We can say that alpha is positive for metals, and from this equation we can also see that rho is depending upon the temperature directly. So with the increase in temperature, the resistivity will also increase. So this is the case for metals. Let us discuss for insulators. In case of insulators or semiconductors, actually the N, that is our number density, is now depending upon the temperature. So in case of metals, the number density is not depending upon the temperature, but in case of insulators and semiconductors, the number density is dependent upon temperature. So now if I will write the same equation, that is rho is equal to m Ne square tau, since here n is now depending upon the temperature, so here we can say that rho is depending upon n, as well as it is also depending upon the relaxation time. So what happens with the increase in temperature? When temperature increases, in case of insulators or semiconductors, the atoms and their covalent bond will break, and the number density, that is number charge carriers, will also increase. And here, since it is depending upon n and also with tau, but the increase in n is more than the decrease in tau. So here we can say that the resistivity is more dependent on the number density. So as with the increase in temperature, the covalent between the atoms or electrons will break, and the number of charge carriers will also increase. So with the increase in n, the resistivity will decrease. So in this case, if temperature increases, resistivity decreases. So we came to know that for metals, resistivity increases with the increase in temperature, whereas for semiconductor, resistivity decreases with increase in temperature. So the graph for metals will be resistivity and temperature is increasing, so it will follow this graph, and for semiconductor, since it is decreasing, it will follow the decrease graph. And for alloys, just like few materials like nichrome, manganese, constantan, they are having weak dependence of resistivity